regarding our DDW project. So our problem statement is, how might we predict the probability of food shortage based on locations' food density, GDP per capita, and average height per person? So food shortage here is based on Global Hunger Index, the GHI of 2022. And we are interested in tackling this problem because this issue has been rampant and growing throughout the years. And in order for us to brainstorm a solution for it, we must first be aware of the cause factors and the variables that basically caused food shortage in the first place. So we are interested in finding the correlation of all these variables to GHI. So to look at our data sets, first we have the GHI data, which is the country and the global hunger index. Then the GDP data, which is fresh from our raw from our source, and we are only interested in the per capita column over here. Then our compiled data, we are interested in food density and height. And food density has already been calculated beforehand here in Excel using the formula of the country's import in USD plus its export in USD all over its population. Then the average height was derived from getting the average height of the female plus the average height of the male of the country divided by 2. And these data were gotten from raw sources as well. Okay, now those are our data sets. We can now proceed into reading them. So to read the GHI data, all we have to do is simply do pd.read.csv, and we change the global hunger index into GHI. And it is important to note here that we are dropping all the countries that do not contain a GHI data. So if the cell is left blank, then the whole record gets dropped. Next, we are going to read data for GDP per capita, and we are only interested in the per capita column here. So any country that doesn't have the per capita value will also be dropped as a record, and we are going to just simply rename per capita into GDP. So the same process for food density, and the same process for height, average height. So we are dropping all the records that do not have values inside of it. Then we are going to merge all our data together. So it is important to note here that country is our primary key, hence why merging the GDP data of all countries to this GHI data will mean that all the respective GDP values of a country will then merge to the country's GHI. And all empty GDPs, even if there are GHI values, these records will be dropped from our data frame. So the current data frame will be looking like country and GHI only, and GDP. Then we're going to proceed with our other two merges, which is the same process as the first one, except we're going to merge this first merge with the second merge, and then this third merge. So with all the merges happening and dropping all the records that do not have values for everything, this is going to be our final data frame that we are going to work with. It has the columns country, GHI, GDP, food density, and height. So our target column here will be GHI, since it is the variable that we want to explore correlations with these other variables. And this variable will also determine how high or low our food probability shortage is. And GDP, food density, and height, these will all be our feature columns. Okay, so we are going to determine the success of this model if our overall adjusted R-square value is higher than 0.25. So first we are going to prepare the feature targets. And to do that, we first need to get the feature targets. And as mentioned earlier, these are our feature values, GDP, food density, and height. Then we are going to split the data. We are using a 0.5 test size here because we want to test half of our data. Then we are going to prepare our features by first normalizing it, then preparing it using this function right here. Then we are going to prepare our target as well. Then we're going to build our model. Our model is a linear regression one, as it describes the dependent variable, so in this case, the probability of food shortage, which is represented by GHI. And since we're not doing a classification model here, or doing anything about classification, then we do not need a logistic regression model. So to obtain the beta of all our features, we would like to calculate its gradient descent. Then from there, we can do our predictions. So to evaluate our model, we first got the R-square score. But then we realized it will not be as accurate because we have three predictors in this case. So we opted to look for the adjusted R-square instead. So R-squared describes how much variation of the GHI is and how much it is actually caused by GDP, food density, and height variables. However, the adjusted R-square is basically this, except it will be adjusted according to the number of predictors, so 3 in this case. And we would also like to evaluate our model using the MSE because this way we will know how accurate the model is. So the closer the MSE value is to 0, then the less errors the model contains. So after getting our R-square score here, we then got our adjusted R-square, in which it shows here that we obtained a data of 0.17, which falls under our 0.25 mark. So our model here is not successful. And our mean squared error is at the 47.63%. 47.63. Then we would like to just plot the prediction for GDP per capita. So here we see the difference between the predicted and the actual values. Same with food density and same with average height per person. Here we are just visualizing how accurate our predictions are. So now we need to improve our model. And to improve our model, we then further fine-tuned the data sets that we put in. So our GHI data then becomes this, which includes more countries. So we increased our data set. Density data, we also increased our data set and added more countries. And height data, same as well. We increased the number of countries that we are putting in. And now they are all in separate CSV files. So repeating the process we did earlier, we get these. Then we would like to merge the data again, but this time we're getting 96 rows times 5 columns. Yes, then we are going to do the same, prepare our features, get features, prepare features, and our targets. Then obtaining all the betas for each, getting all the predicted values for each. Then we are going to calculate all the R-square values and all the adjusted R-square values. And here we are seeing that our R-square value actually increased to 0.50, which is above the 0.25 mark. And this is the overall one. And as you can see, the individual variables have correlations as well, as they are all above the 0.25 mark. And as we can see here, we replotted the predictions. And to conclude this, we are now looking at the metrics of the improved model. We are able to see that the adjusted R-square value has increased from 0.17 to 0.50. And here, it proves the success of our model. And the total correlation has increased, which shows that all these variables are indeed contributing to the food shortage probability. And in this case, we're now able to create design solutions that are targeted and that can address each of these variables independently, because now we know that each has correlations with the GHI. And that will be all for our project. But looking at the website that we created, here we are seeing with these files, these various HTML files, we have index, average height, food density, and GDP. And for purposes, we are going to be opening this with localhost. Okay, so our model, we can just input any values that we want here. Let's say 0.30, average height 160. Then we can predict the global hunter index to be very high, which is 22.15. So we can calculate our adjusted overall R-square here. Then we have these 3 pages as well we can go to. So let's go to average height. And we are able to see the correlations of the average height of the country with the GHI. And then we can see average height as well. Same thing. Food density and GDP per capita. So yes, and we can go back to making a prediction and re-entering new values. And the photos change every time. And yes, it is important to note here that we only used HTML files. So to open it, we just have to click the HTML file. Then we will then be able to see the web page. That is all. Thank you.